Sometimes I like to do a video about intermittent electrical problems. I hope you guys are having a good Monday, even though it is early. And so I'm going to go ahead and punch through this. I've got a part 2 to this. It's going to come out next Monday, so stay tuned for that. But intermittent electrical problems is something anybody that has worked on vehicles professionally, or even worked on them a lot yourself, has run into these intermittent electrical problems that have to be dealt with. And there's a few little tips and tricks that you can do. Back in 1977, I worked at a shop here in town called Davis Auto Service, and Mike was the lead mechanic. He was a really good one too. I had seen Mike, he could rebuild a 350 turbo hydromatic transmission so fast that the torque converter hadn't cooled off by the time he got ready to put it all back in there. But anyway, he went head to head with a 75 Monte Carlo that would intermittently lose ignition power driving down the highway. That's Mike, you see over there on the right. That's what he looked like back then. Right now, he actually is the, manages the local school bus shop, and he's good at it. He's just really sharp about everything he does. But anyway, that one day, this HEI system on this car, and that's what they had back then. You might remember the ones that came out later that had the computer hookup on a computer command control, had a module that had 5 pins on one side and 2 on the other and that kind of thing. But this particular one was the real simple one. You know, that on this one here, you got to remember the coil was actually in the distributor cap like that. This wire, they're showing you how it's wired here, but this coil was actually in the cap, so that the side of the coil that was facing down was what fired this, you know, right here. And so, and it would sort the spark out. That's what the coil looked like whenever you didn't, you know, whenever you were going to put another one in there. But anyway, that HEI system was very, very, very simple. This wire here actually plugs in up in here. And then if you hook a power wire up, so the battery wire, there was terminals here, you know, these terminals right here I'm talking about. You hook a battery wire here, this would be the tack terminal, and these wire here came from the pickup coil. And so that's pretty much all there was to it. This ground is what the module used to fire the coil. In other words, it would actually use that to close and open the primary. So here we go. Mike says, I'm headed out Bellwood Road, and if I'm not back in 30 minutes, you need to come hunt me because this thing has quit. And so I got busy doing whatever I was doing, and I realized, oh no, 45 minutes has gone by and he's not back. I got to go find him. So our shop truck, this looks exactly like it. I jumped on the shop truck and I headed out there, and I found him beside the road doing the slow burn. He'd been leaning on the fender of the car. And he really needed help to find out if he had spark or not. But he was short-sighted enough, which was not like him at all, that he had forgotten to bring a screwdriver or anything to check for spark. So he looked in the back of the shop truck and he found a piece of heater hose. And he cut that piece of heater hose about 8 inches long, and he stuck his pocket knife, he had a kind of a fat pocket knife, and he stuck it in there, and he shoved the pocket knife, one of the pocket knife blades, the skinniest one, up in the wire where it would touch the spark plug, and he was going to hold it and let it and see if it was jumping spark. But what he didn't factor in was that the fiberglass strands in that heater hose will conduct that spark just about as good as any spark plug wire. When I spun that thing over, the spark had come back and it fired him up. Of course, that was him, that wasn't me. But anyway, what it turned out at the end of the day, that this bulkhead connector they had a pushback pin, and it was just barely touching, and that was, but the bulkhead connector looked like this on that car there, except it had a lot of this, you know, gummy black dielectric grease in it and all that, keep those terminals from oxidizing. But anyway, when we figured out what was wrong with it, that's all it was. But that was an intermittent issue, so he had to drive it and get it to quit. Now, intermittent electrical problems can come from other things too, like bad parts can cause that, not just wiring. I had that, I think I mentioned that Ford Probe. It was one of the, like a 90 model, one of those early ones. that had that Mazda power plant in it, and they said it would quit while driving, and I usually like to let one run and see if it'll quit that way, and it just wouldn't do it. It ran for 2 hours and it wouldn't quit in my service bay. And so I got on it and I headed up around the bypass, and before I even got half a mile from the dealership, this thing quit, and I had to go over to the turnaround lane in the, between the 2 lanes of road. And I told you I mentioned this before, but I disconnected the windshield washer and I cooled off the module with it. I propped it up over so what was coming out of the windshield washer would go over the distributor, which is where the module was. And whenever I wee like that, and that windshield washer fluid did a dandy job of cooling that distributor down, so I started it up and drove it back to the shop, put a module on it, and the car was fixed and never had any more trouble with it. But intermittent problems are like that. You got to gather good data to determine what's wrong, so you'll know that your fix will keep it from. And see, what's aggravating is you may feel like you have it fixed, but then you drive it and it doesn't do it for you. But if it's going to do it again, it's going to do it before the customer gets, in other words, it's going to put the customer down if it's not fixed. So you got to be as certain as you can that it's fixed, especially if it's a quitter. If it's windshield wipers or something like that, that's different. Well, intermittent electrical issues can be really deadly if it's something like the stoplights. If the stoplights aren't working every time, and we've seen those, I've seen them where they say sometimes my stoplights don't work from what people are telling me. We would check them, and there would be a blown fuse sometimes. Like, for example, if it's a blown fuse due to an intermittent short, fuse is blown, replace the fuse, you drive it around, it doesn't act up. If the customer comes back the next day, the fuse is blown again. It's a momentary short circuit, just very, very briefly, enough to blow that fuse. And so in extreme circumstances, when you got a couple of choices here. You can either keep piddling with it until you find it, or you can run a completely new wire, which sometimes spreads out everywhere. I'll talk about that again in a minute. But you can actually, what we did was we would get a self-resetting circuit breaker, and we would wire that up with customer permission. We'd say, we're going to put this circuit breaker, it's like having a fuse that will replace itself after you only have a momentary short. And that way the brake lights will typically always work, because the short was only there just very briefly, we figured out. But anyway, and there were several times we had to do stuff like that, but we didn't like to. I'd rather find out what's wrong. However, if you know the problem is on a circuit and you know how that circuit's wired, it's smart to just start at the source and run another wire to the load, and make sure that there aren't any branches coming off of it on the way. Like I say more about that in a minute. Now, when a short or an open's consistently present, it's not always easy to pinpoint the location in some of these thick wire harnesses that go all over the place, and when they're really thick and stiff, they can rub against stuff. I had a picture I should have put on here of this big wire harness that rubbed against the aluminum air conditioner suction line until it rubbed into the harness, and it caused all kinds of electrical problems. Those junction boxes on the F-150s for several years, like starting in 1997 up through the early 2000s, well, up until about 2000, those silly things would drip, the water would drip from the windshield, and it would drip onto that junction box, and you would have electrical problems that might be all over the map. Like for one time we had one that the speedometer would work until you hit about 30 miles an hour, and then it would drop to zero. That was because of that junction box. It can also be for other reasons, but that junction box was the cause of all kinds of weird electrical problems. Because so many things came out of that box, you could have electrical problems ranging from one thing to another, to engine stalls or whatever else, because of that water dripping on that box, and we had to replace those junction boxes. I usually would use some laminate material that I had that we use for laminating documents, and get a real thick piece of that and fix it like a little raincoat, because you really couldn't see the leak, but you knew it had to be leaking water on it because there was water damage in the junction box. Now, the smartest thing to do, like I said, is you run another wire. But if it's spider webs all over the place like this one, that means you got to run a wire to every other place where, if you don't pick the right leg, you're going to be in an issue. Like, for example, if the short's on this leg and you just run one from this splice up here, you hadn't done any good. If the short's on that leg, and you replace, let's say, these three, you still hadn't done any good. You still got a problem. See, and there's circuits like that that spider web out all over the place. We just think of a wiring harness as a car's nervous system, so that's basically what it is. It's carrying signals all over the car. You know, there's current carrying circuits, there's signal circuits that don't carry a lot of current, but it's really important signals. There's all kinds of, you know, actuators, inputs, outputs, just about anything that you can imagine in a car's wire harness, you know. And you know, some of the times we would have intermittent problems because some yo-yo had stuck something in a fuse, you know, where the fuse goes in there. They actually put one of those little, they used to have a little thing you could put on the fuse and shove it in there, and you could tap off some power right there. The problem with that was when you put that thing around the fuse blade, it spreads that terminal in the fuse box, and then when somebody pulls the fuse out and that thing falls off, if somebody's not using it anymore, when you plug it in, you've basically got a terminal that's not touching. And you know, I don't know how many times I saw that. And you'd be looking for an electrical problem, you trace it right back to the place where the fuse was. So if you pull the fuse for the circuit in question and look at those terminals and check pin fit, a lot of times you'll find a problem there, and you got to get a little pick or something if you can. A lot of times you can't get in there and fix that, but that's just really annoying when somebody spreads terminals like that. General Motors instructor one time said that unplugging and plugging a GM connector in, some of them, unplugging and plugging it in 4 times begins to cause pin fit issues because those pins are that delicate. Well, this particular vehicle here, the AC compressor wiring was damaged by the belt, and it was repaired and rerouted. You know, spinning belts and pulleys are really good wire cutters. Remember that one I had the cam sensor wire that had been breached by the pulley that it was laying next to, and the pulley was metal, so it shorted it out. Well, this one here went in and just cut the ground wire, and the compressor wouldn't run. And when we went to check the compressor circuit, you know, coil circuit, it was open. And when we followed the harness, we found this. So we basically put some more loom on it, fixed the wire, soldered everything, and pulled it back up out of the way, and, you know, made sure that it was wire tied so that it couldn't happen again. And but you know, original. A lot of the times, people, whenever they're putting a timing belt on some of these Asian cars, the crank sensor wire runs right down next to that belt, and they'll forget to secure the crank sensor wire, and then the belt will cut the wire, and then you got a no-star sitting beside the road down there, and you look. And you know, they say, hey, after you put my timing belt on, my car quit. Well, surely it can't be something I did. Well, you go and look, and you didn't, you know, you let that wire get over against that belt, it's going to cut it. And then there's these components that move and keep bending the wires until they break them. Some of the Ford stoplight switches used to do this. You know, all the way up into the 90s, you know, the little stoplight switch, when you mash the brake, it had if the wires aren't configured so that they got a lot of bend that can happen in other places, you're eventually going to break the wire. This is a 2006 Impala that the girl said it wouldn't go into, I mean, it wouldn't come out of park, even if she mashed the brake. The shift interlock was mounted on the shifter on this, and so when she pulled that shifter back and forth, it bent that wire until it eventually broke the wire off, you see, and that was the deal right there. So this is where that was. It basically, the shift interlock solenoid wouldn't do anything. And you can go down in there if you pull some of it off and push a button to get it out of park, but that's not easy for any customer to do. And so we wound up having to, you know, replace those wires. And if you do it right, you can basically solder the wire back on there, and you do it rare. I've shown that on some of my other videos where it'll slide right back up in that original connector and go click and be just really good. But what I had to do was I had to lengthen those wires enough so that and put little curlies in them so they would have enough bending so they would not break again. See, it doesn't happen on every 2006 Impala or every moving component, but if the wires are fixed, if the harness is anchored so close that it bends that wire, you know, back and forth, back and forth, back and forth, eventually it's going to break loose. That's just how that works. Now, when you're chasing an intermittent, you need to have some kind of visual and or auditory way of knowing when your harness manipulation causes problems. I mean, if you're wiggling the harness and you inadvertently fix it, and you don't know where you were when you inadvertently fixed it, you might think it's fixed, but then it works its way back over there like it did previously, and you got to come back. And so what I would always do is get onto the circuit while it was shorted, and I would, you see the test light right here, I was kind of gently holding that into that pin while the harness was manipulated somewhere else. And whenever I was watching it really carefully, and when the student moved the harness, this light would wink off and on. And I said, "Oh, stop right there, what are you doing?" And you could go right to the problem if you have an instant indicator of when the short happens and when it goes away. But you only need to, if you're looking for intermittents, you don't need to pull around on wire harnesses to start with. You need to just look and see if there's anything touching. You might remember the story of that expedition that I worked on. I actually saved Ford from buying it back because it would start honking the horns and everything when it rained. And so the field service engineer went down there and had them replace all the door switches because he thought it was something to do with the perimeter anti-theft. But I found out when they finally got it from that other dealer to where we were, that vehicle didn't even have perimeter anti-theft, so replacing those door switches didn't do anything anyway. And so I got to looking, I just looked with my light down in there, and I knew that the wire that triggered the horn relay was a dark blue wire. Now this one had passive anti-theft on it, which was made to honk the horn if you mashed the panic button and all that. I'm sorry, it had active anti-theft, the wrap module where you mash the fob. All right, so I'm sitting here, and I saw that blue wire against the bracket, and I looked down there with my bright light, and I pulled that wire back away from that bracket, and I saw copper, shiny copper, where it had been rubbing against that bracket until it touched. And when the moisture was there, it was a little easier for it to work. When it's bouncing, it confused so the electronics in that wrap module, and it would cause the lights to flash and the horns to blow. And when I saw that, I thought, this is the only thing that could be causing this. And so I pulled it back, taped it off. They never had the problem again, and Ford didn't have to buy that expedition back. And so, there's a little bit of pressure there. But the interesting thing about it was I found it by just looking really carefully and knowing what I was looking for. And it just so happened I got to where I could see it. Now, sometimes it'll be where you can't see it, and that's annoying too. But have something, some meters have got a buzzer on them. I've seen some meters that they'll make a little buzzer. If you can hook some kind of a little buzzer box that you create into a circuit so that it's buzzing whenever the short is there, and then in other words, you got to hook it up between the hot and the circuit, so the buzzer box will be buzzing when the short circuit's there. You can move that short circuit, then wire if that buzzer stops. That you actually got a really good trigger of knowing when you fixed it. All right. You can build a rig like this pretty cheap. They used to, Snap-on used to sell something that had a circuit breaker in it like this. It's a great help in finding short circuits. You can also buy these little fuse buddies down here, like on Amazon. You can get those blade type fuse tester. I think if you look that up, you'll find it. And that's what I got plugged in here and connected to this. And the way that works is you connect a light bulb to these two terminals, and you connect these two terminals, which is a self-resetting circuit breaker. You need to make sure that the circuit breaker you choose is rated at about the same amperage as the circuit that you're checking. Because if you put a 30 amp breaker and you're checking a 10 amp circuit, you're going to burn wires up. Now if you're checking a 10 amp circuit, I got this 8 amp circuit breaker, so that it wouldn't burn the wires up, but it would open and close the breaker when the short was there, you see. And I found all kinds of problems with this thing. But I also have another one out there that I had bought long years ago from the tool truck. I ought to dig it out and show it to you. And it had a little circuit breaker in it, and it had a little magnetic volt gauge in it that would move, and it help you find the short and all that kind of hogwash. But they also have these things that you can basically feed a signal into the wire and then go along here with a detector and find it. And, that's sort of hit and miss on that. On this one here, using this circuit, we actually found we had a Chevrolet truck and it was throwing a mass airflow sensor code, and the mass airflow sensor wasn't the problem. There was no power feeding the mass airflow sensor, but the power that fed the mass airflow sensor also fed other things, including the 4 oxygen sensors that was on the Chevy pickup. And so I hooked this thing up, and it was going ting, 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 ting. And so we went out and unplugged the oxygen sensors, and we got the one that was on one of the rear oxygen sensors behind the catalyst. When we unplugged it, the light quit flashing. That oxygen sensor was internally shorted, and that's how we found that one. But we had a mass airflow sensor code because we had a shorted bank 2 sensor 2 oxygen sensor. Now, the shorted branch of the circuit can be identified by the temperature of the wire, if you got a temperature gun, or by the fact that only one of the loads didn't lighten up when the breaker's closed. All right, this right here is just how this works. See that? See where I've inserted a short here, and that goes out through here. I have actually felt to the wires though and felt the hot one and figured out which way it was going. But you decide the best way to do it because every vehicle is different. That's just the way that is. Now, the Kirchhoff's law is that all the way through the whole circuit, if you look, I've got amps listed out here and volts listed in here. It's going to be amps. The same, this is talking about a 1 amp fuse, so don't be confused by that. But the amperage is the same even on the ground side. It's always got the same amount of amps. But when you're measuring volts, because ground is your reference, you're not going to read voltage down here, but there will be amperage down here. See what I'm saying? So the amperage is going to be 2 amps, 2 amps, 2 amps, 2 amps everywhere, all the way through that whole circle. You're going to have 2 amps. This is what that is. So that's one of them. And all the voltage drops, every connection, every switch, everywhere you've got any kind of connection, there's going to be a little bit of voltage drop in there. Sometimes you'll have a lot of voltage drop because of a bad connection. But if you add all those voltage drops up, let's say you're dropping, let's see, let me see if I can make this happen. If you're dropping 0.5 there, and you're dropping, let's say at this thing, you're dropping, well, you're going to be dropping them on either one side or the other. And if you're dropping a 0.8 here, you know, if you add these up, and you're going to always add in, well, obviously the load's going to be dropping the rest of it. So, you know, 8 and 5 is 1.3, so 1.3 minus, you know, that's 10.7. So you're going to have 10.7 here, and you're going to be dropping at this switch connection here, and maybe at this connection here. I put an amp meter there, but we'll use that. Then if you add that, this, and that, you're still going to come up with this source voltage. That's what that basically means. But you can have voltage drop on the ground side or the hot side. Everybody knows that. The dark side is powerful. Well, that's going to finish up this little short presentation, and I really appreciate you guys watching, and I will see you next time around.